We're going to have a look at worksheet number 15, question 4 that we had for homework last night. It says, find the tension in the rope that separates the two objects. Now, this tension is an internal force, just like maybe the coupling between two train cars would be an internal force, right? The coupling between two train cars doesn't make the train itself go forward, but it does make a certain car within the train go forward because it connects the two. Just like this, this rope that joins these two together, which is really what we're trying to find here, the tension in this rope that separates the two objects in the diagram. This doesn't pull the system forward or backward or anything else, but rather it does pull one particular object forward or backwards, right? It acts between one object within the system and the other object within the system to help pull part of the system forward. So this is what we want to find here, Ft. I'm going to call this guy over here F1. I'm going to call this guy over here F2. Now, if you remember from yesterday, in order to find an internal force, we have to analyze the system first. So let's do that. Let's analyze the system. And with the system, remember, you're always going to analyze external forces. Only external forces. No internal forces here. Okay, just F1 and F2. So we're going to say for this one, the net force is equal to the sum of the forces. What is the sum of the forces here? What forces do we want to include here? What forces do we want to include here? Joshua, will you give me an answer then? Yeah, so F1? Yeah. Are we including F2? Yes. Are we including Ft? No. Only external forces here, so it's F1 plus F2. Now, you could have a problem where there's 3 or 4 external forces, right? This one there's only 2. It doesn't make it that much harder. You just have another 1 or 2 forces to add or subtract. Now we're going to say M times A is equal to the sum of the forces. We've done this part of it so many times over the last couple of weeks. This should be old hat to you by now. Now, what mass do we use? 25, 10, or do we use 35? And what mass are we going to use here? Yeah, we're going to use 35 because we're analyzing the entire system here. We don't know what the acceleration of the system is. F1 is negative 150 because it's to the left, and F2 is positive 250 because it's to the right. So we're going to say 35 times A is equal to, it's 100, right? On the right-hand side. Yeah, 35A is equal to 100. And we're going to say A is equal to 100 divided by 35. 2.857 meters per second squared. Okay, good. It's not what we're looking for, but it's a step along the way, right? We're pretty much half done now. Okay, now let's analyze one particular object, one object. And when we analyze one object, we got to look at the internal force now, plus the external, but not necessarily all of the external forces, just the ones that are acting directly on the one object. Which object do you want to pick? How many people, when they did this for homework last night, picked the 25 kilogram object? Okay, good. How many people picked the 10 kilogram object? Nobody. All right. Probably the 25 kilogram object, because in the example yesterday, I picked the back object, the second object as well, but whatever. Okay, let's do the 25 kilogram object. Then we'll do it the other way as well, just to kind of demonstrate to you that it does work out to be the same answer. So if we're analyzing the 25 kilogram object, let's draw another free body diagram of that object. Here's my 25 kilogram object. I've got a force to the left, we're going to call it F1, and I've got a force to the right, we're going to call it Ft. Right? The 10 kilogram object pulls on the 25 kilogram object. The rope does, that is, with a force that we're going to call Ft, the tension in the rope. So now we're going to say F net is equal to the sum of the forces. That's F1 plus Ft. There is gravity and normal force here, right? But they cancel. So we're not going to worry about those. M times A is equal to F1 plus Ft. What mass do we use? 25, 10, or 35? Yep. We're going to use 25 this time. We're analyzing just one object, and its mass is 25 kilograms. The acceleration of that object is what? We know it, right? We know it. What's the acceleration rate of that object? Yeah. If the whole system accelerates at 2.857 meters per second squared, then each individual object will as well. Now F1 is still negative 150 plus Ft. We're going to calculate that. Now let's get the calculator for this one here. We're going to say 25 times 2.857. That's my left side. Take the 150 over by adding, and I get 221.425. Where should I round that to? How many digits? How many? How many digits? 2. Yeah. So we're going to say 2.2 times 10 to the 2 newtons. Good? How many people got that? Excellent. Good. Let's take a look at the 10 kilogram object as well, okay? We don't have to, right? We've got our answer here, but let's do it as if we analyzed the 10 kilogram object here. And just to demonstrate that we're going to get the same answer here. So here's my 10 kilogram object. The 10 kilogram object is being pulled to the right by a force of 250 newtons. We're calling that F2. And it's being pulled to the left by the rope, by the tension in the rope. Now, even though like the 10 kilogram object is going to pull the 25 forward, okay, if the 10 pulls the 25 forward, then the 25 is pulling the 10 backwards with an equal and opposite force. So it's that same tension there. Okay, you're just acting one way on one object, acting the other way on the other object. Let's say F net is equal to the sum of the forces, Ft plus F2. Let's say M times A is equal to the sum of those forces, Ft plus F2. M is 10. A is 2.587. Now tension, we don't know. We just solved for it, right? But we're pretending we don't know it here because we're solving it as if we hadn't analyzed the first object, the 25 kilogram object. F2 is 250. So we're going to say 10 times 2.857 is 28.57. We'll take the 250 over by subtracting. Let's figure out what this is on the calculator here. Although, really, we don't need to because I know what it's going to work out to be. Look at that. Negative 221.43. Or we're going to say negative 2.2 times 10 to the 2 newtons. Is it a coincidence that we got an equal and opposite force? If object A applies a force on object B, then object B will apply an equal and opposite force on object A. Now, you don't have to do it both ways here. You absolutely have to do this. And you absolutely have to do one of these, either the top one or the bottom one, but not both. Now, having said that, if you have extra time on your test, which by the way is next Wednesday, a week from tomorrow, if you have extra time on your test, you're done and you're looking at your watch, it's like, I got 15 minutes left. Do it the second way. It's a nice little check, right? If you do it the second way and you get the same answer for the tension, 2.2 times 10 to the 2 or whatever the case may be, get the same answer both ways, the odds of you being correct are almost 100%. Like you can't have the wrong answer. It's almost impossible to have the wrong answer if you get the same answer twice. Does that make sense? Now, if you get a different answer here versus here, when you're checking it over, then that tells you that I made a mistake somewhere, so I got to go back and check things over. One of them might be right, or they might both be wrong. But at least you can go back and check. You know that you've made a mistake somewhere.